Good one. In the last lecture, we seen that some basic definition. Okay, linear transformation, linear operator, linear functional, and range of T, nullity of T. Okay, null space of T and rank of T, and also rank nullity theorem and the definition of dual space. What is dual space? The collection of all linear functional on a vector space V over F. It's called as dual space. Okay, so it is denoted by V star or LVF. LVF means what? This one. Set of all linear functional on the vector space V over F. Okay, so that LVF is equal to T such that T is the linear functional form VF to F, which is linear. Okay, now again, we see in one theorem statement. Okay, let V be an n-dimensional vector space over the field F, and let beta is the basis. Okay, ordered basis of n vector space V over F, then there exists a unique linear functional F on V such that F of alpha I is equal to xi. That is, for every different element of the basis, we have different images. Okay, not for one function. Okay, yeah, प्रत्येक एलिमेंटच्या alpha 1, alpha 2, up to so on alpha n, we have different images. That is xi for all I running from 1 to n. Okay, any doubt up to here?
No, sir.
Okay, now we will see the proof of this thing. Now, first one. First, we have to prove that existence of f. Okay, first we have to prove that there exists a function f. Okay, on v over f to f. Now, first, we have to prove that existence of the functional f. Okay, now look at here. Let alpha belongs to any element from the vector space V. Okay, be any element. Okay, now since beta is the basis of V over F, since beta, it is the basis alpha 1, alpha 2, up to so on alpha n is what? Ordered basis. Is ordered basis of V over F. Okay, vector space V over F. Then the element alpha we can write in the form of linear combination of alpha 1, alpha 2, up to so on alpha n. Okay, so then there exist unique scalars a1, a2, up to so on an. Okay, in
F.
F, capital F, the field F, such that we can write this alpha is equal to a1 alpha 1 plus a2 alpha 2 plus a3 alpha 3 plus up to so on an alpha n. Why? Because this is the basis of V over F. Beta is the basis of V over F. So any element we can write uniquely. Okay, this word is important, uniquely. So alpha is equal to a1 alpha 1 plus a2 alpha 2 up to so on an alpha n. Okay, now we define one rule f from V to F. Okay, we define a rule, that is one mapping. Now define, here we are going to prove the existence of the function. Okay, so here we define one rule, define a rule, that is a map or map f from V into capital F. Okay, this is the small f from what? V into capital F. That is, f is the function from what? V into capital F. Okay. So here we define a rule small f from V into capital F such that hmm, f of alpha, alpha belongs to capital V, okay, which is equal to, but what is alpha? Alpha is nothing but a1 alpha 1 plus a2 alpha 2 plus up to so on an alpha n. Okay, so that is f of alpha is equal to a1 as it is, and f of alpha 1 is what? x1 plus a2 x2 plus up to so on here an xn. Okay, where x1 x2 up to so on xn are belongs to capital F. Okay, so where, look at here carefully, where the set x1 x2 up to so on xn be ordered set of scalars, okay, from F, capital F. Okay, suppose the image of alpha 1 is x1, image of alpha 2 is x2, alpha 2 is x2, up to so on image of alpha n is xn. Okay, so here we define a rule f from V into capital F. If x1, x2 up to so on xn belongs to capital F, then a1, a2 also up to so on all the ai's belongs to F. So hence this addition must be in capital F. Okay, so output f of alpha, image of alpha belongs to capital F here. Okay, now here we define a rule. Okay, now we have to prove that this function, this mapping is a well-defined mapping. Okay, so in the second step, we have to prove that this small f is well defined. That means we have to check that this mapping is a function. Okay, well defined check करते हैं मुझे क्या करते हैं अपन? What is the method to prove the well defined?
F of x1 not equal to f of x2 implies x1 not equal to x2.
If or if alpha is equal to x1 is equal to x2, then f of x1 is equal to f of x2. Okay,
Yes, sir.
negation of this set. Okay, so we have to prove that here the f is well defined function. Now take alpha belongs to the vector space, and this alpha we can write in the form of a1 alpha 1 up to a2 alpha 2 up to so on an alpha n, where alpha r belongs to beta, that is basis, and another one, and one more element beta is equal to b1 alpha 1 again b2 alpha 2. Now the scalars are different. Okay, but and plus Vn alpha n. These are the two elements belongs to capital V. Okay, that is vector space V over F. And what is f of alpha? F of alpha is equal to f of a1 alpha 1 plus a2 alpha 2 plus up to so on an alpha n. By the definition of f, what we have? This is a1 x1 plus a2 x2 plus up to so on an xn. Okay, similarly, and f of, okay, small b, beta is equal to f of beta is equal to give this name as a not beta, okay, capital B manayala. Okay, assume this is a capital B. Now f of beta is equal to f of b1 alpha 1 b2 alpha 2 plus up to so on bn alpha n. And by the rule f, the image of this one is b1 x1 b2 x2 plus up to so on bn xn. Now let alpha is equal to beta, and we have to prove that f of alpha is equal to f of beta. Okay, if we prove f of alpha is equal to f of beta, then the function is well defined function. Okay, now let alpha is equal to beta. This implies what is alpha? A1 alpha 1 plus A2 alpha 2 plus up to so on an alpha n, which is equal to b1 alpha 1 plus v2, sorry, okay, correct, v2 alpha 2 plus up to so on bn alpha n. Okay, so this implies a1, a2 up to so on an r belongs to the field f, and now here b1, b2 up to so on bn r belongs to again f. Okay, so there exists a additive inverse of b1, b2 up to so on bn, and alpha 1, alpha 2, and alpha up to so on alpha n r belongs to again v. Okay, this element belongs to v. This element also belongs to v. Okay, so there exists a additive inverse of each element of this one, b1 alpha 1, b2 alpha 2 up to so on bn alpha n. Now take towards the left side. Okay, actually the left side ला घ्यायचं नसतं बरं का. a1 minus b1 into alpha 1. ओके, डिस्ट्रीब्युटिव्ह प्रॉपर्टी वापरली आपण. इनवर्स आधी इनवर्स घेतलाय त्याचा आणि त्याचा डिस्ट्रीब्युटिव्ह प्रॉपर्टी यूज केला. ओके, प्लस a2 minus b2 into alpha 2. Any doubt?
No, sir.
Up to so on an minus bn into alpha n is equal to 0. Okay, which is equal to right hand side is 0 vector. Okay, this implies a1 minus b1 is equal to
Equal to
each
0.
coefficient is 0. Okay, a2 minus b2 is equal to 0 up to so on an minus bn is equal to 0. This implies ai is equal to bi for all I. Okay, or I running from 1 to up to so on n. Okay, so this gives if a1 is equal to b1, a2 is equal to b2, up to so on an is equal to bn. This implies what? F of alpha is equal to f of beta. So this gives f of alpha is equal to f of beta. Thus, f is well defined function. आता याला फंक्शन म्हणू शकतो. ओके, ऑन कॅपिटल V. Okay, any doubt up to here?
No, no, sir.
Okay. Now, आता हा फंक्शन प्रूव्ह केलाय आपण. आता हा लिनियर पुन्हा प्रूव्ह करायचा आहे. ओके, नाव इन द थर्ड स्टेप we know that each alpha I, okay, basis element belongs to V can be uniquely expressed as, look at here, each alpha I is equal to 0 into alpha 1 plus 0 into alpha 2 plus up to so on plus 0 into alpha I plus, sorry, 1 into alpha I plus 0 into alpha I plus 1 up to so on alpha n. Any doubt?
No, sir.
Now, but take the image of this one. F of alpha I is equal to, okay, f of 0 into alpha 1 up to so on 0, oh, sorry, 1 into alpha I plus up to so on 0 into, this is 0 into, sorry, alpha n. Okay, by the definition of f, this is equal to f of alpha I is equal to what? 1 into xi. Okay, so this implies f of alpha I is equal to xi for I running from 1 to 3 up to so on n. Okay, by the definition of f. This is the reason. Okay, so there exists a function f such that f of alpha I is equal to xi. Now we have to prove that this function is a linear function. Okay, now in the fourth step, we have to prove that the condition of linearity. Okay, next, to prove that capital F is small f is linear functional, linear functional on capital V. Any doubt in the above steps? One, two, three.
No, sir. So,
Okay. Now let alpha and beta are the two elements belongs to V and C belongs to capital F. B any scalar. Okay, C is the any scalar. Okay, so then we can write this alpha is in the form of linear combination of basis element. That is, alpha is equal to summation I running from 1 to n ai into alpha I. Similarly, beta is equal to summation I running from 1 to n bi into alpha I. Okay, now to prove the condition of linearity, consider f of c into alpha plus beta is equal to f of c into what is alpha? Summation of ai alpha I running from 1 to n plus summation I running from 1 to n bi into alpha I. Okay, so this is equal to f of okay summation I running from 1 to n c into ai plus bi into alpha. Okay, any doubt up to here?
no,
Alpha
sir.
taking common, okay, from the both the summation. Okay, c into summation ai or summation of c into a, both are equal. Okay, 3 plus 4 घ्या किंवा 5 into 7 घ्या, दोन्हीचा आन्सर एकच येईल ना. Okay,
Yes, sir.
so here f of summation I running from 1 to n c into ai plus bi into alpha I. Now by the definition of f, this is equal to, wait a minute. By the definition of f, this is summation. Okay, this is the coefficient now. I running from 1 to n as it is. This is belongs to f, this is belongs to f, this is belongs to f again. Okay, the whole bracket belongs to what? Capital F. Okay, so here summation by the definition of f, summation I is equal to 1 to n c into ai plus bi alpha I transformed to xi.
Exact.
Okay, any doubt up here?
No,
No,
sir.
sir.
No. Okay, so this is equal to now summation I running from 1 to n c into ai into xi plus summation I running from 1 to n bi into xi. Okay, so this is equal to c into summation I running from 1 to n ai into xi plus summation I running from 1 to n bi into xi. So this is equal to what is this one? F of
F of alpha.
is it correct? F
F
of
of alpha,
alpha plus F
F
of
of beta.
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 Okay, now here f of c alpha plus beta is equal to C into f of alpha plus f of beta. Thus, thus f is linear functional. Function prove केला आधी नंतर linear prove केला. Okay, linear functional on V such that what is the condition? F of alpha I is equal to xi from I running from 1, 2 up to so on. Yeah. Okay. Now one more step is there. Uniqueness. Okay, there exists काय म्हटलं आपण unique. Look at the statement. There exists a unique linear function. Okay, हा एकच आहे प्रूव्ह करायचं आहे. Okay. Now in the fifth step, the uniqueness. We have to prove that the uniqueness. Okay. काय याची स्टेप काय समजा दोन अजून करायचे दोन फंक्शनल एक्झिस्ट होतात असं अजून करायचे आणि ते दोन्ही वेगळे नसून एकच आहे प्रूव्ह करायचं. सो लेट G be any other linear function. Any other linear functional. Okay. Such that on capital V such that if G of alpha I is equal to xi. For I running from 1, 2 up to so on n. Okay, now take element. Let alpha belongs to V. We can write alpha is equal to A1, alpha 1 plus A2, alpha 2 plus up to so on An alpha n. So what is G of alpha? G of alpha is equal to G of A1 alpha 1 up to so on An alpha n. Okay, so here the G is what? Linear functional. So G of alpha is equal to, now take outside A1. Now this is G of alpha 1 plus up to so on. Why? We can write this because G is a linear function. Okay, so this is An into G of alpha n. So G of alpha is equal to A1. What is G of alpha 1?
x1.
X1. X1 plus A2, X2 plus up to so on. This one is An Xn. Okay, so by the definition of small f, we have this is G of alpha. What is right hand side? F of alpha. For all alpha is the any element, any arbitrary element from V. So this is true for any alpha belongs to V. So G of alpha is equal to F of alpha for all alpha belongs to V. Okay. The दोन function total V वर जर equal असतील तर then G is equal to what? F on V. Okay. So this proves the uniqueness of F. Any doubt? Okay, सगळे थेरम इझी आहेत फक्त त्याला बस वाचता आहे एकदा पुढचे थेरम घेतल्यानंतर मागचे थेरम लक्षात येत नाही. ओके look at here once again. What we prove, let V be the n-dimensional vector space over the field F and beta is the basis of V, then there exists a unique linear functional F on V such that F of alpha I is equal to xi for all I running from 1 to n. Okay, first we have to prove that the existence of F. Okay, for this one we define one function F like this, F of alpha is equal to a1 x1 a2 x2 up to 1 an etc. Okay, then this rule we have to prove that this rule is a function that is well defined. Okay, so here we prove that F of alpha is equal to F of beta, hence this rule is a well defined function now on V. In the third step, to prove that there exists this function maps alpha I to xi. Okay, And in the fourth step, we have to prove that this linear function, this f is the linear function, condition of linearity. And in the fifth step, the uniqueness. Okay, any doubt? Hmm. Any doubt up to here?
No, sir.
Okay. Now, I want to ask one concept. Do you know chronicle delta? Anyone knows chronicle delta? Delta ij is equal to 0, where I is not equal to j and is equal to
Equal
1.
to 1.
I is
I
equal
equal to
to,
J.
and this delta is nothing but chronicle delta. Okay. Now the next theorem is statement. Let capital V be finite dimensional vector space over the field F, over the field capital F. Let B, okay, is equal to alpha 1, alpha 2, up to so on alpha n, be a basis, be a basis for capital V. Then there exists then there is uniquely determined basis beta b star, not beta, b star is equal to f1, f2, up to so on fn. Okay, for v star such that fg of f5, sorry, f5 of alpha j is equal to delta ij. Okay, that is equal to 0 when I is equal to not equal to j, that is equal to 1 when I is equal to 1. म्हणजे काय असेल f1 alpha 1 1, f1 alpha 2 0, f1 alpha 3 0. Okay, look at the statement once again. Let V be the finite dimensional vector space over the field F and beta is the basis for the V. Then there is a uniquely determined basis. Okay, that is there exists a basis beta star of V star. Okay, what is V star? Dual space of V, collection of all the linear functional on V. Okay, तर तो काय होतोय dual space आहे itself a vector space and this beta star is equal to f1 f2 up to so on fn is the basis for V star. That means we have to prove that this beta star is linearly independent and span of beta star is equal to V star. That means every element belongs to V star. We can write in the form of linear combination of f1, f2 up to so on f1, which is uniquely expressed. ओके, हा बी कोणाचा बेसिस आहे या व्हीचा. हा बी स्टार कोणाचा बेसिस प्रूव्ह करायचा आहे आपल्याला व्ही स्टारचा. व्हॉट इज व्ही स्टार? व्ही स्टार इज नथिंग बट ड्युअल स्पेस ऑफ व्ही. ओके, ड्युअल स्पेस ऑफ व्ही म्हणजे याच्यात एलिमेंट कसे असतील? फंक्शनल्स असतील, लिनियर फंक्शनल. कोणावर? व्ही वर. ओके, एनी डाऊट?
No, sir.
V star is equal to, write down in the bracket, V star is equal to T such that T is the linear functional from V to F. Okay. Collection of all the linear functionals on V. Okay, with composition हा काय तयार करतोय पहा, टेक्स्टबुक मध्ये असेल. Collection of all the linear functional on vector space V forms a vector space. Okay, with काय असेल ऑपरेशन कॉम्पोजिशन. And for that vector space, we have to prove that this beta star, this B star is equal to F1, F2 up to so on Fn is a linear, sorry, is a basis for B star. And this beta star is unique. Okay, एखाद्या वेक्टर स्पेसला बेसिस युनिक नसतात. ओके, आणि हा जर तुम्हाला हा व्ही आणि बी बी दिला असेल तुम्हाला अल्फा 1 अल्फा 2 अप टू सो ऑन फॉर धिस वन. Okay, for this V and for this B, there is uniquely determined basis B star. Okay, now look at the proof now. Any doubt in the statement?
No, sir.
Okay, माहित नसेल तर येत नसेल कळत नसेल तर विचारा पुन्हा. Let capital V be a, write down all the given statement. Sorry, proof. Okay, let B is equal to alpha 1 alpha 2 up to so on alpha n be a basis. Basis for capital V, and assume this set 1 0 0 up to so on 0. Okay, up to n times P any ordered set of n scalars. Okay, so by previous theorem, there exists a unique linear functional F1 on capital V. Okay, such that F1 of alpha 1 is equal to what? 1. F1 of alpha 2 is equal to what? 0 up to so on. F1 of alpha n is equal to 0. Okay, हा झाला F1 साठी. By again consider the ordered set 0 1 0 up to so on 0. Okay, so again by previous theorem, there exists a unique linear functional F2 on V such that F2 of alpha 1 0, F2 of alpha 2 is 1, F2 of alpha n is 0. Okay, so in general we can write in general for each I running from 1 2 up to so on n, there exists a unique linear functional instead of f1 f2 right now fi. Okay, on capital V such that fi of alpha j is equal to 0 when I is not equal to j, and which is equal to 1 when I is equal to j. Okay, हा जर दोन इक्वल असतील तर 1 येईल. F2 alpha 2 1, F3 alpha 3 1, Fn alpha n is 1. Okay, if I is not equal to j, then the value becomes 0. Okay, so that is nothing but fi of alpha j is equal to delta ij. Okay, canonical delta म्हणतो त्याला. Any doubt?
No, sir.
ओके, आणि प्रत्येक वेळेस पुढचा थेरम सांगताना मागचा थेरम आपल्याला इथे यूज होणार. ओके, त्यामुळे लक्ष द्या व्यवस्थित. आणि मधनच तुम्ही लेक्चरला प्रेझेंट राहिलात अबसेंट राहिला तर पुढचं नाही करणार काही. ओके, नाव लेट बीटा स्टार और बी स्टार इज इक्वल टू f1 f2 up to so on fn. Okay, Now, obviously, these are the functionals on V. F1 is the functional on V. F2 is the functional on again V. Okay. So obviously, this beta star, sorry, this B star is the subset of V star. Okay. Obviously, this B star is what? Subset of V star. Basis हा त्याचा वेक्टर स्पेसचा काय असतो? सबसेट असतो. Okay. Now we have to prove that this B star is the basis. Okay. For the basis, we have to prove that this set is linearly independent and this spans whole vector
And
space
the
V star.
B-star.
Okay. So first one, to prove that V star is basis for V star. Okay, V star म्हणजे काय? Dual space of V. We call the collection of all linear functionals on V. Okay, ह्याच्या पुढे डबल dual येईल. त्याच्या पुढे ते नीट लक्षात ठेवा. Okay, so let consider any n scalars in capital F such as C1 F1 plus C2 F2 plus up to so on Cn Fn which is equal to काय येईल?
Zero.
लिनियरली इंडिपेंडेंट प्रूव्ह करायचं आपल्याला. इक्वल टू काय करावं लागेल?
Zero.
Zero.
कॅप. हा झिरो म्हणजे तुमचा झिरो एलिमेंट नाहीये. झिरो इज द लिनियर फंक्शनल. ओके, त्या वेक्टर स्पेस मधला झिरो घ्यायचा. ते वेक्टर स्पेस काय तुमचा? ऑल सेट ऑफ ऑल लिनियर फंक्शनल. म्हणजे हा झिरो फंक्शनल काय करतोय? त्याच्यातल्या प्रत्येक एलिमेंटला काय करतोय? तो झिरोला मॅप करतोय. ओके, झिरो फंक्शनल आहे हा. झिरो इज द लिनियर फंक्शनल, not the element of V. Okay, it is the element of V star. Okay, any doubt?
No, sir.
Okay, C1 F1. If we prove C1 is equal to 0, C2 is equal to 0, up to so on, all the Ci's are equal to 0, then all F1, F2, this set is linearly independent. Okay, now apply this linear function on alpha. So this implies in the bracket C1 F1 plus C2 F2 plus up to so on, this is Cn Fn. Okay, the addition of all the linear functional is again linear functional. Okay, so this apply on this functional apply on alpha. Okay, this is also linear functional. So 0 cap of alpha for all alpha belongs to capital V. This implies हा वेक्टर स्पेस तयार करतो म्हणजे हा काय होईल? डिस्ट्रीब्युटिव्ह होईल. ओके, नो, हा प्रत्येक फंक्शनलवर अप्लाय होईल. C1 F1 of alpha 1 plus C2 F2 of alpha, sorry, not alpha 2. C1 F1 of alpha 1 plus C2 F2 alpha plus up to so on Cn Fn of alpha. And 0 of alpha is what? 0 linear function is 0. For all alpha belongs to P. Okay, so this implies summation I running from 1 to n Ci Fi of alpha is equal to 0 for all alpha belongs to capital P. Any doubt up to here?
No, sir.
No, sir.
तुमचा फॉर ऑल अल्फा बिलॉंग्स टू व्ही म्हणतो. प्रत्येक अल्फासाठी व्हीच्या प्रत्येक एलिमेंटसाठी फॉर ईच अँड एव्हरी एलिमेंट ऑफ व्ही दिस इज ट्रू. Okay, but we know that the B is what? Alpha 1, alpha 2, up to so on alpha n. Okay, this is what? Subset of V. Okay, so alpha 1 belongs to V, alpha 2 belongs to V, alpha n also belongs to V. So now apply this on basis element. Okay, why? Because the basis is the subset of vector space. So this implies summation I running from 1 to n Ci Fy of alpha j now, okay, is equal to 0 of alpha j is 0, where j running from 1 to up to so on what? Yeah. Is it correct?
Yes, sir.
ओके. एकूण किती अल्फा आहेत आपल्याकडे? 1 1 to n. फक्त तिथे नोटेशन वेगळं आहे. आय नाही यूज करता काय केलं मी? जे यूज केलं. ओके. नाव this implies summation I is equal to 1 to n Ci Fi alpha j is nothing but what? Delta ij. Here. Okay, any doubt?
No, sir.
Okay. Now, which is equal to 0. Okay. Now, run I. Okay. For j is equal to 1. ओके. आता दोन रन होते इथं. आय पण रन होतं आणि जे पण रन होतं. आधी आपण जे कॉन्स्टंट ठेवलाय. पुट जे इज इक्वल टू 1 and run I. What we have then? C1 delta 1 J1. J1 आहे ना तुमचा. काय येईल? डेल्टा 1 डेल्टा 1 1 प्लस रन I C2 डेल्टा 2 1. Is it correct?
Yes, sir.
प्लस जे कॉन्स्टंट आहे तुमचा C3 delta 3 1 up to so on Cn delta n1 is equal to 0. Okay, now this one is what? 1. Delta 1 1 is 1 because I is equal to j here. So this is C1 plus and all the other values are 0,
0.
which is equal to 0. This implies C1 is equal to 0. Okay, now for j is equal to 2, what we have? Run I now.
C2 equal
C1
to 0.
delta 1 2 plus C2 delta 2 2 plus C3 delta 2 3 plus up to so on C and delta which I then equal to 3 3 2 J2 again. Okay, 3 n 2. Okay, is it correct?
Yes, sir.
Suffix like 2 2 2 2. Now here this one is 0. This one is C2. This one is 0 up to so on. 0 is equal to 0. Okay. So this implies C2 is equal to 0. Okay. Similarly, for j is equal to 3, 4 up to so on n, we get C3 is equal to C4 is equal to up to so on Cn is equal to 0. Okay. That is if C1 F1 plus C2 F2 plus up to so on Cn Fn is equal to 0. This implies C1 is equal to C2 is equal to up to so on Cn is equal to 0. This implies F1 F2 up to so on Fn is linearly independent. So this implies beta star is linearly independent. Any doubt?
No, sir.
Okay, now in the second step, we have to prove that beta star spans V star. Okay, any linear functional from this star we can write in the form of F1, F2 up to so on Fn. Second step, to prove that beta star spans V star. That is, linear span of beta star is equal to V star. Now for this one, take any f is linear function. Any linear functional in V star arbitrary घेतलाय बघ. Now we know that a function will be completely determined if we define it. If we define it on basis for v. Okay, एखादा फंक्शनल जर माझ्या v वर मला डिफाइन करायचं असेल, ओके, मी प्रत्येक एलिमेंटची इमेज नाही काढणार आहे. त्याचा बेसिस कोण आहे? समजा बी त्याचा बेसिस आहे अल्फा 1 अल्फा टॉप अल्फा n. जर मला या बेसिस एलिमेंटची जर इमेज मला मिळाली तर मला पूर्ण वेक्टर स्पेसचा काय होईल? मला प्रत्येक एलिमेंटचा काय मिळेल? मला इमेज मिळेल. इज इट करेक्ट? Okay, a functional will be completely determined if we define it on basis for v. Is it correct?
Yes, sir.
काय म्हणतो कळते का मी? एखादा फंक्शन मला वेक्टर स्पेसवर डिफाइन करायचं आहे, म्हणजे मला त्या वेक्टर स्पेसच्या प्रत्येक एलिमेंटची मला इमेज काढायची असेल तर मी त्या प्रत्येक एलिमेंटची इमेज नाही काढणार. फक्त मी बेसिस एलिमेंटची जर मला इमेज जर मिळाली तर माझं प्रत्येक एलिमेंट वी कॅन राईट इन द फॉर्म ऑफ लिनियर कॉम्बिनेशन ऑफ दिस बीटा if we define the image of this one alpha 1 alpha top to so on alpha n, then we can define any image of alpha belongs to v. Is it correct?
Yes, sir.
Okay, past statement value. We know that a functional will be completely determined if we define it on a basis of capital P, or basis for V. ओके, एखाद्या बेसिसवर आपण डिफाइन केला तर तो पूर्ण वेक्टर स्पेसवर डिफाइन होईल. ओके, and let the image of alpha, okay, that is the image of each and every element of basis is equal to ai. आपण असं अजून केलं for I is equal to 1 up to so on n. Okay, so to show that we have to show that what we have to show, f is equal to this is the linear combination of f1 plus a to f2 plus up to so on an fn, which is equal to summation ai for I running from 1 to n. Okay, any linear functional we can write in the form of f1 plus f1 f2 f2 so on fn. Okay, and त्याचे coefficients काय असतील? a1 a2 up to so on n, such that f of alpha I is equal to ai. म्हणजे हा कोणाचा इमेज आहे? अल्फा 1 चा इमेज. अल्फा 2 इमेज ऑफ अल्फा 2 इमेज ऑफ अल्फा n. ओके, एनी डाउट? ओके, आपल्याला शो करायचं ना. एनी डाउट?
No, sir.
Now we know that the two linear functionals, okay, on capital V are equal if they are agree on a basis of capital V. त्याचा अर्थ काय? जर दोन लिनियर फंक्शन असतील तर इक्वल कधी असतील? त्या वेक्टर स्पेसवर जर त्यांचे बेसिस इमेजेस तर सेम असतील. ओके, इफ अल्फा 1 अल्फा टॉप टू सो ऑन अल्फा n is the basis for V. Okay, if f of alpha I is equal to g of alpha I for all alpha for all I running from 1 to n. Okay, the two linear functional are equal on their basis, then both the linear functions are equal. Okay, so let this alpha I or alpha j belongs to capital V, where J running from 1, 2 up to so on N. Okay, now apply this functional on this one, alpha J. Summation I running from 1 to N AI Fi of alpha J is equal to summation I running from 1 to N, which is AI. Okay, so this is Fi of alpha J. Okay, but Fi of alpha J is what? Delta Ij. Okay, so this is equal to A1, then I now. Okay, then I. So A1 delta 1j plus A2 delta 2j plus up to so on. Aj delta jj plus aj plus 1 delta j plus 1 j plus up to so on an delta n j. Is it correct? If we run I. Okay. Yeah, 1 to n मध्ये कुठेतरी तुमचा j असेल. So this is equal to the value of this one is aj into 1. Okay, and left hand side is what? Summation I running from 1 to n ai fi of alpha j. But what is aj? By the definition of f, this is f of alpha j. Okay, look at it. What is aj? F of alpha j. So this implies summation I running from 1 to n ai fi of alpha j is equal to f of alpha j. Okay, for j running from 1, 2 up to so on n. Okay, हा तुमचा एक linear function. हा तुमचा एक linear function. Okay, they both are agree on basis element. Basis element काय? Alpha 1, alpha 2 up to so on alpha. So this implies both are equal. म्हणून तो वरचा स्टेटमेंट घेतला. कळतंय? So I running from 1 to n ai fi is nothing but f. So this implies f is equal to a1 f1 plus a2 f2 plus up to so on an fn. Is it correct?
Yes,
काही
sir.
डाऊट आहे काही? बघा, हा एक लिनियर फंक्शनल झाला तुमचा. हा एक लिनियर फंक्शनल. बोथ एग्री ऑन basis element of v. This implies both the functions are equal. Okay, एखादा वेक्टर स्पेस असेल v आणि त्याचं समजा हा तुमचा बेसिस असेल अल्फा 1 अल्फा 2 टू सोन अल्फा n. Okay, and g of alpha I is equal to f of alpha I or I running from 1 to up to so on n जर असा असेल, then this implies g is equal to f. असं लिहितो ना आपण.
Yes, sir.
तोच लिहिला इथे. जर बेसिस वर इक्वल असेल तर होल वेक्टर स्पेस वर इक्वल असेल ऑन व्ही. हा तुमचा लिनियर फंक्शनल. हा तुमचा एक लिनियर फंक्शनल. बोथ एग्री ऑन अल्फा जे, that is j running from 1 to n. So both the functions are equal. Hence f is equal to a1 f1 plus a2 f2 up to so on an f1. That is every element of v star can be expressed as a linear. Okay, f हा तुमचा arbitrary element आहे. So any element or every element of V star can be expressed as the linear combination of f1, f2 up to so on fn. This implies B star is basis for B star. Okay, any doubt?
No,
No,
sir.
sir.
Okay, ना एकदा पास स्टेटमेंट काय दिसायला दिसतं खूप सोपं आहे पण लिहिताना आठवत नाहीये बरं का त्यामुळे प्रॅक्टिस हवा खूप what is the statement? Let V be the finite dimensional vector space and B is the basis for V. Then there exists a unique basis F1, F2, up to so on Fn, that is B star for V star, such that alpha I F of Fi alpha j is equal to delta Ij. Okay. The examples on this theorem we will see in the next lecture. Okay. Up to here, any doubt? काही डाऊट असतील तर विचारू शकता. Okay, so thank you for the attending the lecture. You can leave now. Okay, thank you.